Good evening, everyone. In this video, we'll be talking about multiple inheritance. We'll be discussing multiple inheritance, multiple classification, and workarounds for its implementation. Okay, so let's look at the things one after the other. Multiple inheritance actually permits a class to have more than one superclass. Okay, until now we have seen like a single inheritance. Okay, so basically a class is inheriting another class, so that means like there is a generalized class. Okay, so we are actually inheriting that one. Okay, and then like we also have seen multiple levels of inheritance. Okay, multi-level inheritance, but we are looking at the next concept. The multiple inheritance actually permits a class to have more than one superclass. Okay, and that way like it will be inheriting the features of all its parents. Okay, so say for example class A is there, which is inheriting class B and also class C. That way like it is getting the features of both C and B and C in A. This is a more complicated form of generalization than single inheritance. Single inheritance actually restricts the class hierarchy to be a tree. Okay, this we have already seen. That's what I have been discussing. Okay, so multi-level inheritance actually we have seen the hierarchy to be a tree, isn't it? But this multiple inheritance is a little bit more complicated thing. Okay, than that. Okay, we'll be seeing the examples. Then everything will be clear for you. There are several advantages of using multiple inheritance. One is like now we will have greater power in specifying the classes. Okay, because like you are getting the features from multiple classes, and then like we will also have the increased opportunity for reuse as well. Okay, so that's also an advantage. But the biggest disadvantage with this multiple inheritance is we will be losing loss of conceptual and implementation simplicity. The simplicity of the generalization is already lost by this sort of multiple inheritance, and implementation is also not so easy. Okay. If we really think in terms of conceptually, the term multiple inheritance is used somewhat imprecisely in that sense. Okay, so generalization is the conceptual relationship, and more or less like inheritance is the language mechanism. So basically, if we say like Java has the inheritance, but object-oriented design will have the generalization. So it is the conceptual relationship. Okay. So instead of multiple inheritance, it should have been called like multiple generalization. Okay. But of course, like if you say multiple generalization, probably not many people will understand until and unless like they really apply object-oriented design concepts and then like think in that lens. Okay. There are different types of multiple inheritance. Okay. The most common form of multiple inheritance is from sets of disjoint classes. Okay. So each subclass inherits from one class in each set. Say for example, we have already seen like in generalization, we have this sort of generalization set name. Okay. Say for example, the employee, okay, can be a full-time employee or a part-time employee. Okay. So the generalization set name there is employment status. So employment status will actually make him whether it is a full-time employee or a part-time employee. Okay. This is a disjoint set in that sense. Okay, disjoint classes. So class is set. Okay, so for this generalization. Similarly, like say for example, there can be another generalization with its own generalization set name, managerial status. So an employee can be a manager or an individual contributor. Now the interesting thing happens tomorrow. Like if you want to basically design a class for full-time manager, then it is ideal to basically inherit or generalize from this full-time employee and the manager. You got the point? So if you want to have this sort of full-time manager, this is basically inheriting full-time employee and also like manager. Similarly, like if you want to have a, say for example, part-time employee individual contributor, so you will be basically extending this one and this one. Okay. Of course, like you can have by 2 by 2, that is 4 combinations. So full-time manager, okay, and then like full-time individual contributor, part-time manager, and part-time individual contributor. All of them are possible. The appropriate combinations actually depend on the needs of the application. You don't have to always need to design all the classes. Until and unless like the design actually needs them, you don't have to put all the combinations. Okay. So the appropriate combinations actually depend on the needs of the application. Remember that. Now, in this case, like we have to see like each generalization should cover a single aspect. Okay, so that's what we are actually trying to see here. So this generalization is actually having this sort of employment status. Okay, so each generalization should cover a single aspect. We should use multiple generalizations if a class can be refined on several distinct and independent aspects. Okay, say for example, the employee example we already have seen like two generalization sets. Okay, one is on employment status and the another one is on managerial status. Okay, so such an example we already have seen here. Okay, so a subclass inherits a feature from the same ancestor class found along more than one path only once. Okay, so look at this sentence. Okay, so it is the same feature. So I will give you the example. Say for example, this full-time manager through inheritance, he is also getting the features of employee through this route and also through this route. So basically, like if employee has certain features, something like an employee name, maintaining duplicates of the name, one through this route and one through this route would not make sense, isn't it? Okay, that's what this statement is actually stating about. A subclass inherits a feature from the same ancestor class found along more than one path, but only once. It is the same feature actually. So that's the idea. So employee features in full-time manager. Okay, so you get them through two different routes, but then like it will be the same feature, so you'll be getting them only once. But if you go with this sort of multiple inheritance, okay, conflicts are always common. Conflicts among parallel definitions create ambiguities that implementation must resolve. Okay, so the conflicts are very common. Okay, in practice, like if such a conflict arises, it is better to basically go back, okay, and actually explicitly resolve them at the models themselves. Okay, you have to do this even if a particular language provides a priority rule for resolving the conflicts. Say for example, I will give you an example. So we had this sort of full-time employee dot name, okay, and then say for example, like from the other side as well, the individual contributor or like the manager will also have another name, okay. Say for example, individual contributor has another name. So basically for this example, what I am trying to show is, okay, so going by this full-time employee and then like full-time individual contributor. So that means like if you have a name here, full-time employee, that is the employee name, okay. Whereas if you also have the name as a feature for this individual contributor, most often like this could be defining like the position, okay. So are like more or less like the title of that contributor, okay. So the name actually means the title. Yeah. So if that is the case, if it tries to inherit name from this full-time employee and this from this individual contributor with the same name, the conflicts arise. So later, like of course, if the language provides you a way, okay, to prioritize like which rule to basically use, okay, so which of them features from which of the class should be using, and then like if it device gives you priority rules as well, even then it's a good idea to basically go back, redesign the model and restate the names in such a way that say for example now you can change those names and then like make them a lot more specific. Full-time employee will have a person name and an individual contributor will have a title. Okay, that way there will not be any more conflicts, okay, for this multiple inheritance. Hope that is clear. Multiple inheritance can also occur with this sort of overlapping classes. Okay, see this example. So this would be very interesting. There can be vehicles The vehicles can be land vehicles and then like water vehicles. Okay, a land vehicle can be a car and a water vehicle can be a boat. But the problem is there can be amphibious vehicles. Okay, so which actually can be both land vehicles and also like water vehicles. So this generalization is a overlapping generalization set. Okay, overlapping generalization set. So that means like there can be subclasses or like objects which can actually belong to both these generalized classes. Okay. So UML actually uses a constraint to indicate such an overlapping generalization set. Okay. So we will discuss about constraints in a little bit more detail, okay, in the next videos, in one of the videos, okay. But then like the constraint is mapped something like this one. So you will put the overlapping, okay, and then like a dotted line cutting across this affected generalization, okay, with keyword in this braces, so which is like overlap. Interestingly, it is also incomplete because like this generalization set is not complete. Okay, say for example, not just the land vehicles and water vehicles, there can be flights, okay, so which are flying airborne vehicles, okay. So that way like this generalization set is not complete, okay. So that's what this additional thing is basically telling you. So let's move on. That's about multiple inheritance, okay. There can be multiple classification as well. The multiple classification is another very interesting problem, okay. The classification actually refers to the relationship between an object and its type. Okay. Until now, we have seen only a single classification. In a single classification, an object belongs to a single type. Okay. An object belongs to a particular class. The type may inherit from other supertypes, from its supertypes. Say, for example, like one class. Okay. So we have an object of class B. Okay. So which can inherit, like, say, for example, class A, and class A is inheriting from class C. So you can have this sort of multi-level inheritance. So basically, like whatever this object of A inherit all the features. Okay. So that is like single classification. But there can be situations like multiple classification. In the multiple classification, an object may be described by several types that are not necessarily connected by inheritance. So that makes it actually a little bit tricky. I'll give you 2 or 3 examples. Okay. Later, like I will give you one solution, how you actually do that one. The solutions I will extend the discussion in the coming slides. Think about there is a person. The person can be a faculty, okay, the person can be a student, okay, and he can be a staff in a university. Say for example, University of Hyderabad. Now interestingly, like an instructor can be a faculty or a student. Because like if tomorrow I have teaching assistants, and the teaching assistant who will be most often a student, maybe instructing in one of the labs or like in lectures. So it may happen. Okay. So that means like this instructor is basically getting the features of both faculty and also the student. The same example which we have seen with the amphibious vehicles. So that generalization, like we basically have to put this sort of constraint, okay, so which is like overlap. Okay, up to here it is very clear. Now the problem comes. Say for example, a person from University of Hyderabad also teaches in, say for example, IIT Hyderabad. Okay, just for fun, or like say for example, such an MOU is there between the universities, and then like it can happen. Okay, then how do you show it in this? Okay, even then like you need to have multiple classifications. So that means like that person is actually with this sort of University of Hyderabad and also with this sort of IIT Hyderabad. How do you model that? Okay, so it looks a little bit complicated, isn't it? So that means like that object, whatever it is, that person is having that sort of multiple classification. I'll give you another very simple example for you. A person can be a male or a female, okay, and a person, say for example, like he can be a doctor or a nurse or like say for example some physiotherapist or whatever it is. Okay, so he can also be that one. And a person can be a patient and he is not a patient. Okay, so like that one. So we have three different generalization sets. So sex, which is actually defined by male or female, and whether he is a patient or not, and whether he himself is a doctor or a nurse or some other related with the hospital. Now the point is, so here we have seen like three different generalization sets, and all this. So the male and female are also extending the person, okay, and this patient is also extending this section, okay, extending the person. At the same time, the doctor, the nurse, and all of them are also extending the person. Now, interestingly, so now you have three different generalization sets. And randomly, like if you pick a person, okay, he can be either a female or a male, okay. At the same time, he can be a patient, or he can be a doctor or a nurse or something. So then you basically have to not just like that becomes a multiple classification, okay, because like he belongs to multiple classes, okay, in fact, teachers. But at the same time, like at the implementation level, you need to have a lot of restrictions. Say for example, a person who belongs to, say for example, he can be only a male or a female. Assuming like there are only two different classifications in that. Okay, so I don't care about the third, the generalization, whatever may be possible. Okay, so assuming like if it is a complete set. So a person can't be both a male and a female and also a patient. At the same time, like a person can't be both a doctor and a nurse from the third generalization set. So now you probably got what is the idea of multiple classification. So a multiple classification there can be like, it can be a female and she is a doctor. Multiple classification, she belongs to two classes. Okay, there is a male doctor, okay, and then like say for example there is a male doctor is there, so it belongs to two classes. But the restrictions can be like, okay, so for example he can't be a doctor and he can't be a patient, okay, so we can have such restrictions. He can't be both doctor and nurse from the same generalization. So there can be a lot of restrictions. How do you deal with these things? Coming back to our earlier example, say for example how a person can be basically belonging to multiple universities. There is an approach called delegation, which I will be discussing further in the coming slides. Okay. The delegation approach basically what it says is like, say for example, is a generalization where it is the multiple classification has to happen. You basically separate it. Okay. So you will still maintain the generalization with this university number, and then like you basically use a composition. Okay. I will discuss this in detail in the coming slides. Okay. So basically like this person is a composition of multiple university members. So that way like, so he can have one part from University of Hyderabad, one part from IIT Hyderabad. Okay. But of course like still this overlapping constraint stays the same. So that's about multiple classification. Most object-oriented languages do not support this multiple inheritance. Multiple classification is much more tough. Okay, so most of these object-oriented languages do not support these things. Dealing with this sort of lack of multiple inheritance is not a design problem. Actually, it is really an implementation issue. In fact, actually, you can restructure your model. Early restructuring of a model is often the easiest way to work around this problem. Okay. So as I mentioned earlier, that is the delegation approach. Okay, so I will discuss the delegation approach in detail, but the delegation approach, I mean, this is the delegation approach. So basically like having a class, if it is extending and if it is overlapping, and then like you need to have multiple classification. Okay, so you basically will do that. Not just for multiple classification, it is also useful for multiple inheritance as well. So which I will show with the examples. The basic idea of delegation is an implementation mechanism by which an object forwards an operation to another object for execution. Assume like an object receives an operation to be executed, and then like this object would actually route the execution to the next object. That is the delegation. How the delegation is used, like I will be discussing in the coming slides. Let me take this same example. So the employee, he has one generalization set which is based on employment status, which is like full-time employee or part-time employee. And there is another generalization set which is based on this manager or individual contributor. Okay. Then what we have seen, like this multiple inheritance is based on this full-time manager. Restructure this one, okay, so that like we can have an implementation for this one. We can follow the approach of delegation using composition of parts. This is one approach. Okay, so this is the same thing like which we have seen for this multiple classification as well. Okay, the basic idea is recast a superclass with multiple independent generalization as a combination in which each constituent part replaces a generalization. Okay, let me read it again. Recast a superclass with multiple independent generalization as a composition in which each constituent part replaces a generalization. So we used to have one generalization for the employee with the employment status, another one for this sort of managerial status. Now basically like we still will have this sort of generalization from this employee employment and employee management, and then like we will try to have this sort of composition to the employee, both from this employee employment and also from this employee management. And similar thing which we have seen with this sort of multiple classification, where like that university member, we had that one, we had a new class called university member, and then like for that one which we had this sort of composition for the person there. Here it is for the employee. This approach actually replaces a single object having a unique ID by a group of related objects that actually compose an extended object. So now an employee object will be composed of this employee management and employee employment. Okay, so both these classes will be there. Now the tricky thing and most interesting things will pop up now. Okay, if you have such a model, let us see that. Inheritance of operations across the composition is not automatic. Okay, the composite class, in this case the employee class, must catch the operations and delegate them to the appropriate part. Say for example, if it has to delegate something to the employee employment, it has to delegate to this one, the operation, whatever the operation it catches, it has to route through this route or through the other route through using the composition. Okay, so that is something very important to remember. In this approach, like we need not create the various combinations as explicit classes. That is one advantage. Okay. Say for example, earlier we have all those combinations like full-time manager and then like full-time contributor and then like part-time manager and all those combinations. Like we don't have to create explicit classes for them. But still, like all combinations of subclasses from the different generalizations are possible. Okay, by this delegation approach. Now let us look at another approach. This is like inherit the most important class and delegate the rest. See, for example, like here employee is the most important class here, especially for the employment status. So still have this sort of employee and then like employment status as the sort of inherited classes. Okay, generalization, you preserve the generalization here. Okay, so within this one, okay, and then like employee management, have it as a composition. Got the point? So here like the most important class is generalization is this employment status, and then like the employee is the most important class. Okay, here. So now the point is like you can create any of these objects. Okay, so and then like you can still have this sort of say for example a full-time employee, and then like you can have this sort of employee management as a composition class. Okay, as the composition featured by you. See, by extending, like you are also getting all the features for what the employee has. So full-time employee has the access of this thing. That means like full-time employee, if he wants to call, say for example, something for a manager, feature or like some operation. So he has to basically take that part from the composition and has to delegate the operation to the manager. Okay, that's the tricky thing. There is another approach called nested generalization. The idea of this nested generalization is like factor on one generalization first, then the next. Okay. So basically, like say for example, if we go by the same example, employee, first factor on this sort of employment status, and then like you will have full-time employee and part-time employee, and then like factor on this sort of full-time employee status generalization segment. Okay, so then you already have this sort of full-time manager, full-time individual contributor, part-time manager, part-time individual contributor through this generalization. This approach actually multiplies out all possible combinations. Okay, so here we have generalization sets only two, and then like there are only two options. But think about something bigger. Okay, so you will be multiplying them, so the combinations will be pretty huge. And if you also have this sort of multi-level inheritance, okay, so then that is a disaster there. Okay. This type of nested generalization actually preserves the inheritance, but actually duplicates the declarations and code, and in fact actually it violates, okay, the spirit of object-oriented programming. Okay, so that is something very important to them. Okay. So if we try to summarize these sort of workarounds for handling this sort of multiple inheritance, okay, if you have multiple superclasses, okay, if all superclasses are of equal importance, then use delegation. Okay, the way like we have seen. Okay, and discussed in this video. Alternatively, if you have one dominant superclass, okay, preserve the inheritance through this path and have delegation for every other path. That example as well, like we have seen. If the number of combinations is small, consider nested generalization. But if the number of combinations is pretty huge, like don't use nested generalization at all. Okay. And if we are using this sort of nested generalization, okay, factor on the most important criterion first, then the next most important second, and so forth. Say for example, if one of the generalization has only two, okay, two sets, T10 sets, another has 5 disjoint sets, don't start with 5, okay, start with the 2, okay, then go with the 5. To be frank, like actually like try to avoid nested generalization if we must duplicate large quantities of code. Okay, so it is not advisable. Okay. But remember this one. If it is not at all advisable, like why we really have to use this nested generalization at all. One of the very important features of object-oriented thing, which we have discussed to be almost the first feature, is identity. An object should be able to identify itself with a class. Only nested generalization preserves strict identity. Okay. So in terms of object-oriented concepts, especially from the identity side is concerned, it is preserving. But at the same time, like it is failing with every other object-oriented feature, because like we can't reuse the code. It will also, like we have seen those problems, all its problems. Okay. So this is again from chapter 4. Okay. So multiple inheritance. Okay. Thank you very much for your attention.